Last class we started in this example يا شباب 3 phase 5 kVA 208 volt 4 poles 60 Hz star connected synchronous machine has negligible stator winding resistance, so Ra equals 0, and synchronous reactance of 8 ohms, so XS equals 8 ohms طبعا per phase at rated voltage. The machine is first operated as a generator in parallel with 3-phase supply with the same voltage and frequency. We solved with number A, which was determine the excitation voltage value of EF and the power angle. So we got the value of EF and power angle at or when the machine is delivering rated kVA. We solve with this on external file on Word, okay, and here we will see the solution together. So V phase equals 208 over square root of 3 because it's star connected or Y connected, and the stator current can be calculated as S rated, which is given 5 kVA, over square root of 3 multiplied by 208 volt. So this is the rated current. And the power factor is given as 0.8 lagging, so we can easily substitute now in the equation. EF equals V terminal at angle 0. All of time V terminal will be at angle 0, plus IA multiplied by JXS. So V terminal is 120 at angle 0. The current is 13.9 at angle minus 36.9, طبعا minus because it's lagging, multiplied by 8 at angle 90, which is JXS. And the value of EF as phase equal 206.9 at angle 25.5. By the way, شباب, we can solve also in the same way by per unit calculations. يعني we can say that I base equals I rated, which is 13.9 here, and then we can say at full load يبقى I A at full load equals 1 per unit, and V terminal equals also 1 per unit. So we can say EF equals 1 at angle 0, which is V terminal, plus JXS. We need to get XS, we need to get Z base firstly. طبعا you know Z base equal V base over I base, and I base equal S base over V base, so it's now V base square over S base, which is S base is 5 kilovolt ampere, so this is 5,000, and V base is nothing but phase value of volt, which is 120 here, so it's 120 square. So this is Z base. So we can say now XS M per unit equals 8 ohms divided by the value of Z base. تمام يا شباب? Is it clear? So we can substitute now EF equal V terminal 1 at angle 0 plus JI equal 1 at angle minus 36.8 multiplied by XS M per unit. So we can calculate in this way. Finally, if we would like to get the excitation value in actual value, taking the value here and multiply it by the value of V base. So finally we can say EF actual phase equals EF M per unit, which has been calculated here, multiplied by V base. تمام يا شباب? Any question in per unit calculations? Right. Number B, if the field excitation current is now increased by 20%, so EF in case number 2 compared to EF in case number 1 is extra by 20% because it's increased by 20%. So we can say EF2 equals 1.2 multiplied by EF1. صح كده يا شباب؟ Without changing the prime mover power, which means the power is A is constant, P is constant. Find the stator current and power factor, or power factor and reactive kVA supplied by the machine. ها شباب, how we can calculate the current and power factor by knowing EF, the excitation value. Who can solve with me?
Yes, we find the armature current first.
We find the armature current, yes.
Okay, and then we find
in case number 1. But now the excitation is changed. The current
we can find the power angle.
How?
By equating the by equating both
cases, excitation or power?
I mean power, sorry.
Power, صح? Because we said here it's constant power. So now يا شباب we can say EF1 sine delta 1 equals EF2 sine delta 2. صح? Because we have EF sine delta constant at constant power. So we have EF1 and EF2 is 1.2 EF1. We have delta 1, so simply we can get delta 2 from this equation. If you have delta 2, so the vector EF2 is well known now, so you can calculate current using the Kirchhoff voltage law of the circuit. تمام? So the solution. Now, comparing the power for the two cases, we will have EF sine delta in case number 1 equal to EF sine delta in case number 2, and we can get the value of delta. As you can see, delta has been decreased. Yani delta was 25.5, delta now is 21. This means the excitation is increased or decreased, يا شباب?
I think increase.
Exactly. It's already stated, it's increased by 20%. So if the excitation increased, the power angle will be decreased. So this is now logic. تمام يا شباب? The answer here is is logic. 21, يعني power angle has been decreased. Fine. After getting delta, simply we can use the relation IA equals EF minus V terminal over JXS. يعني you can substitute easily here. طبعا EF now is 1.2 multiplied by the first value, so this is the case number 2, and this is the power angle, and this is V terminal JXS. So simply we can get the current at case number 2. طيب طبعا الباور فاكتور شباب is nothing but the power factor, the cosine angle of current, because V terminal is reference. So we can say now power factor is cosine 51.5, which is 0.62. طبعا lagging because the current angle is minus. طيب, what is the value of Q? How we can calculate Q يا شباب? طبعا يعني there are two different ways to calculate reactive power, either by using the general formula of the reactive power, 3V phase I phase sine phi, or you can calculate it using the relation of Q equals طبعا 3 because 3 phase multiplied by EF V terminal over XS cosine delta minus V terminal square over XS. صح يا شباب? This is the other relation to calculate the reactive power. طيب يعني طبعا يعني if you calculate by the two ways, the values have to be similar. طيب, any question يا شباب in this part? Anything is تفضل.
I wanted to ask about how can we calculate the reactive power in the second option?
You have
How we-
EF in the second case, صح? You get it already here. This is the value of
Yes.
EF. And you have XS. You have the value of delta as well. So all values here are given now, or well known here. صح ولا غلط? So you can substitute
Yes.
easily, huh? ماشي يعني we can say Q equals 3, huh? You have EF 248 by 2 by value of V terminal, which is 120 over XS, it's 8 ohm, cosine angle of delta, which is 21, تمام, minus 120 square over XS, تمام, يعني substituting the same relation, يعني it should be the same value. طيب. هي it's already calculated here by the same by the other way شباب. تمام, يعني it's here. طيب, number C. With the field current as in A, يعني we can use now EF for part A, the prime mover power is slowly increased. So at the same value of excitation, the prime mover power, like turbine for instance, start to be increased. So we expect to have extra output power. So power here will change and the excitation will be constant. It's opposite to what happened in part B. Part B, excitation has been increased and the power was constant. So it's opposite here. But here we will keep the excitation as in part A, the previous one. So the power here will be changed. Only excitation is constant. طب what do you expect يا شباب when the power increase and the excitation is constant? What should happen to the power angle?
It increase.
Exactly, it should be increased because the power will be increased. تمام. So what is the steady state or static stability limit? This means يا شباب or firstly, what is the steady state? What is the steady state or static stability limit? We should say that static stability limit is the case at which the power angle is 90 degrees. صح كده يا شباب? Which is the point of maximum power. And what are the corresponding values of the stator or armature current, power factor, and reactive power at this maximum power transfer condition? So at maximum power transfer condition, which means delta equal 90 degrees, with the same value of excitation in part A, we need to calculate or repeat the calculation of current, power factor, and reactive power. Is it clear, شباب? So,
Yes.
part C, with the maximum power condition where delta equal 90 degrees, we can now substitute in the equation B max equal 3EF, which is EF at part 1, multiplied by V terminal over XS. So this is now the maximum power that the machine can deliver. يعني if you remember, the rated power of the machine was 5 kVA. So how the active power يعني to be higher than this value? It's impossible طبعا. Okay. So power here is higher because this is maximum, it's not rated. تمام؟ يعني rated power will depend on the per unit or the power factor value. صح ولا غلط يا شباب؟ يعني all of time if we have power, we can define power factor by the way. Power factor, you know, it's B over S. صح؟ يعني we can say now it's equal to, يعني if we work in per unit now, you will find that P in per unit equal P actual over S base. صح ولا غلط شباب؟ This is the power in per unit, which is P over S. It's similar to the power factor. So power in per unit equals power factor. So if we have 5 kilovolt ampere machine, what will be and the per unit power at rated is 1 per unit. So what will be the per unit value of active power يا شباب? It will be the same as power factor. تمام؟ And it should be يعني equal or less than 1. It cannot be more than 1. However, as you can see here, because this is not rated, it's maximum, the power is higher than the value of the base power of S apparent power. Okay? Type, because this is maximum. So after getting the maximum power, now we can substitute in the relation. We have the values to get current and other needed values. And this is the maximum power, which is the steady state stability limit for our case. IA equals EF minus V terminal over JXS. So you have EF in case number 1 at angle 90 degrees because it's maximum power, minus V terminal at angle 0, divide JXS. So this is now the current يا شباب. As you can see, current is around 30 ampere. The first current, if you remember, it was around 17.8 ampere. This is for case number 2. For case number 1, the current was 13.9, yani around 14 ampere. However, here it's around twice the value or even higher than twice. تمام يا شباب؟ Right. So this is the case of maximum power. What is the power factor? Now we can calculate the value of power factor easily. We have the angle of A of power factor. So cosine 30 is 0.865 and leading طبعا يا شباب all of time. The maximum power will happen at leading power factor generators. يا شباب, maximum power will occur at leading case. ماشي? Where delta is 90 degrees. طيب. The reactive power can be calculated by the same way. However, it's missed here in this part of the problem. So we can say شباب Q equals, similar to the other calculations what we already calculated before, 3 multiplied by V phase, which is 120, multiplied by the current, which is 29.9, multiplied by sine the angle of power factor, which is 30.1. And this will be the value of reactive power. Let's calculate this value. 3 multiplied by 120 by 29.9 by sine 30.1. So the value is 5.3 or 5.4 approximately. 5.4 kilovolt ampere reactive. طبعا يا شباب, if you have a look now, 5.4 reactive power and 9.3 active power. So the apparent power now is, let me calculate, 9320 square root of the answer. So the apparent power يا شباب at maximum, so S at the condition of maximum power, يعني دلتا تساوي 90 درجة. Okay, this value of S here now is 10.8 kilovolt ampere. طبعا it's very high compared to the rated value. ماشي, we said before the maximum is almost 2 times of the rated value. Maximum is almost around 2 times of the rated value, and this is the case here. تمام.
But doctor,
اتفضل.
but we can only have it for a few seconds, right? Or for only a brief moment. We can't have it or make the machine work on it all the time.
Actually, we cannot have it completely, not even for a small time. We said before maximum power point should be recognized in order to avoid the operation at this point. Okay, maximum power يا شباب means the critical point, which means if the current increased a bit over this value, the machine will be damaged. It will be burned. The coils will be burned due to the high current. Okay, and we said before, overload is allowed for certain periods. Type overload for how percent? 10%, 20%, certain value, according to the time as well. And for instance, we can have 10% overload for 1 hour, 20% for instance for 40 minutes. Okay. However, 200 or 100% extra load, this cannot be achieved for even very small time. تمام؟ It's not allowed. تمام يا شباب؟ يعني it can be considered like يعني the cases of short circuits. ماشي؟ يعني we cannot operate the machine at these very high values. يعني almost twice or even more than twice of rated current. تمام؟
Sorry, doctor. In the reality, we'll have the circuit breaker to trip this one.
طبعا 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 there is a course يا شباب called power system protection. There are many protections used for electrical generators, like over voltage, like under voltage, like overloading. Lots of protection schemes يا شباب. يعني you will learn it إن شاء الله if you يعني take this يعني important course. تمام. The next example, synchronous machine in example 4 is operated as a synchronous motor. So now يا شباب, the same machine now will operate as a motor. طبعا يا شباب يعني to be honest with you, يعني if we return to rated values 5 kVA, طبعا it's very small rating. يعني it's not يعني high power for large scale generators. It's just few kilowatts or few kilovars or even few kilovolt ampere. يعني it's small rating. يعني current is only يعني 15 or 14 amps. It's very small values. For that it can work for motor طبعا, or you will find it as a motor a lot in your life. The field, the machine is connected to the same supply. The field excitation is adjusted so that the power factor is unity. When the machine draws 3 kilowatts from the supply. So this is now the input power, and the power factor is unity. What is needed here? Find the excitation voltage, the power angle, and draw the phasor diagram for this condition. طبعا يا شباب, again, we have power, we have power factor. So we can give the value of current. صح ولا غلط؟ يعني we said before, in order to calculate the excitation and power angle, you need loading condition, which can be the value of current and power factor, or value of apparent power and power factor, or value of active power and power factor. Here, active power is given along with the power factor. So you can use it easily to get the value of current and substitute in the equation to get the excitation. So we can say now IA equals 3000. Why 3000 يا شباب? Because it's stated here the machine draws 3 kilowatts. So this is now the operating condition. Take care يا شباب. Sometimes يعني people are confused in this part and they calculate current using the rated values. طبعا rated values is given, rated value is given already in the problem. Okay, يعني you may find in the same problem it's stated that 5 kilovolt ampere, and after that the machine draws 3 kilowatt. 5 kilovolt ampere, it means this is the rated value. However, the machine draws 3 kilowatt. This is the current loading condition. في فرق يا شباب ما بين الماشين الريتد بتاعها قد ايه وانت مشغلها على باور قد ايه. يعني for instance, all of us have air conditions at home, and the air condition is calculated in tons or in kilowatts. Okay, so you may find small مثلا small split units around 2 tons or 3 tons or 2 kilowatts like that. Okay, is it draw 2 kilowatts all of time, or this is only the rated value and it will draw the power according to the condition of your يعني according to the temperature in the place. صح ولا غلط شباب؟
Yes.
تمام. يبقى إذا يعني we should use only the power condition we have, the condition of loading, okay, not the rated value. We can use only rated if it is stated the machine is working at rated conditions. طيب. So now, تفضل.
You mean that if you have a rated value and we have a drawn value of the power, we use the drawn power for.
Yes, yes, this is exactly what I mean. Because it's stated the machine draws 3 kilowatts. This is the loading condition what we have now. However, what is the rated value of the machine? I don't care. I care about the operating condition now. Okay? So we will use the 3000 watts, which is the value of active power. طبعا over 3 multiplied by 120. Where is the power factor? So this is شباب here there is a typo in this. Sorry, power factor is unity. Okay. طبعا يعني here it's written. Okay. طبعا relation يا شباب power or I A equals power over 3 V phase power factor. تمام. But here power factor is unity, so here يعني neglecting right the value of 1. So we got here IA. This is the value of current, 8.3 amps at this rating condition. Now we need to calculate EF. So simply EF equal B terminal minus GIXS.
Doctor?
تفضل.
120 from where they get it?
This is the terminal voltage. We said V line is 208 and V phase equals 120. صح?
Divided by root 3, right?
Divided by.
Yes. V terminal 120 is 208 over square root of 3. تمام؟ طيب. After getting the value of current here يا شباب, we can substitute now in the relation. So V terminal equals 120 over at angle 0 minus, because it's motor now, 8.3 amps at angle 0 because it's unity power factor multiplied by JXS, which is 8 at angle 90 degrees. Substitute here, you will find that the power angle is negative. The power angle here يا شباب is negative. Why it's negative? Is it because of lagging or leading or unity power factor?
Because of lagging.
لا. It doesn't care about the power factor. Here, EF at negative
because
angle.
This is a motor, I think.
Exactly. Because it's motor now. So power angle, شباب, the sign of the power angle, sign, not sinusoidal sign, I mean plus or minus. The power angle is plus or minus according to the power flow. According to the power flow. So the angle delta will be plus if the machine is working as generator, and it will be minus if the machine is working in motoring mode. So here the machine is working in motoring mode, for that delta is negative. Type. Number B, if the field excitation is held constant, so EF will be the same as we calculated in part A. And the shaft load is slowly increased. We increase the power now, which means the power will be increased over than 3 kilowatts. المطلوب, determine the maximum torque. Maximum torque, it means torque at power angle equal 90 degrees. صح يا شباب? Torque at maximum power. So we need to calculate only here the value of torque according to the angle delta equal 90 degrees. Simply, we have the value of excitation. The power angle is 90. So we can calculate the active power. In this case, we can say.
دكتور.
تفضل.
why we didn't say that the angle should be motor, not generator? We said that it is. You said that it should be 90.
I mean absolute value is 90. يعني when you substitute in the vectors it should be minus 90. صح. You're right.
Okay.
طيب. Draw the phasor diagram. We didn't draw the phasor diagram for the first part. Okay. So يعني the phasor diagram will be like that يا شباب. We have V terminal, we have IA in phase, JXS, so this is the angle minus 29. Right. Here we have a note that because of the motor action, the power angle is negative. We discussed this. The phasor diagram is shown in figure. EF delta can also be calculated from the phasor diagram. يعني this is another way يا شباب to يعني let you know how we can use phasor diagram to solve our problem. يعني already we have the value of current. صح؟ يعني we got the value of current. So at unity power factor, you know the shape of phasor diagram. This is a right angle triangle. So you have the value of IA multiplied by XS. And you have also the value of V terminal, this line. So simply you can say EF is a square root of 2 for V terminal square plus IAXS square. Then you can calculate delta based on the values you have. Delta equals tan inverse IAXS, this side, divided by V terminal, that side. So we can get the value of delta using this way. ماشي؟ يعني it's different way using يعني the triangle what we have here. For part B, maximum torque is needed, so simply we can go now and calculate the maximum power. We already calculated EF, and it will be the same, and V terminal is the same. EX is given, so we could get the value of maximum power. So this is the value of maximum power at this excitation value. After that, we need to calculate torque. So simply we can say torque equal power over speed. And you know, speed of synchronous machine is constant all of time. How we can get the speed of the machine? Simply return to the nameplate data. It's given here that the machine is 60 hertz and number of poles was given in the nameplate data of the problem in number example number 4, which is 4 poles. So if we use the relation now, you will find the speed is 1800. So using 1800 over 60 multiplied by 2 pi in order to convert to radian. So this will be the value of torque here, 32.8 Newton meter. And this is the maximum torque. Any question, Shabab? Okay. Now, if you
sorry, the 60 to convert to radian, or because of the frequency is 60 hertz?
لا. The relation of speed to convert speed from omega to RPM, from radian to RPM, we have N equals 60 over 2 pi multiplied by omega. Okay, this is the relation. And if you get the opposite, so omega will be 2 pi over 60 multiplied by n. تمام? This is the relation. طيب. Power factor control. If you have any induction motor at home, this motor will draw reactive power. However, synchronous machine has the advantage of power factor control. So if we have synchronous motor, we can control this motor in order to deliver reactive power, not consume reactive power. And this is helpful because all of surrounding loads will consume reactive power. So you can use the synchronous motor anywhere and adjust the excitation in order to make the power factor in leading condition. This is going to deliver the reactive power to the surrounding loads. And this is يعني helpful to decrease the overall reactive power consumed by the grid. طبعا this is this will decrease the amount of current absorbed. تمام. And at the same time يعني will be safe and have no penalties due to the problems of power factor. You know يا شباب, in domestic applications we don't have this problem. يعني at homes there is no penalties for power factor. However, in industry, if the power factor decreased يعني behind a certain value, certain limit, so there will be penalties for factories in order to achieve better reactive power or achieve better power factor. How we can solve this in our life? By using source of reactive power. Like conventionally, capacitors are used. طبعا there are many advanced techniques like advanced static bar compensator. It's based on static filter along with power electronic converter. It's used to compensate the power factor and control it to a certain value. And also we can use the synchronous motors if it exists already in the factory. We can use these motors and control the excitation in order to keep it leading all of time. So, as you know, this is the phasor diagram for constant power at different power factor values. Here, power factor is leading. Here, power factor is unity. IA1 power factor is lagging. And this is the case for the 3 excitation voltages. So, for high value of excitation, EF3, you will find IA is leading. And for small value of excitation, you will find I is lagging. So the target for any motor operated in factory, the target is to make power factor is leading, not lagging, in order to achieve or get better performance in terms of overall power factor in the factory. تمام يا شباب؟ there is an experiment inshallah we will discuss in the next week. It's regarding the relation between armature current and field current. This relation is called V curve. Why it's V? Can you see here يا شباب? Assuming we operate the machine at certain loading condition where the power is constant. So if we start with a small value of current at IF1, we will have small value we will have high value of armature current, and have a look here for case number 1, EF1, the current is lagging and the current is high. تمام يا شباب؟ If we increase the excitation, which means increasing in field current, what is happening to the current يا شباب? To the armature current.
It goes to leading.
It will decrease up till reaching to unity power factor. صح؟
Yes.
جميل. So, according to the phasor diagram here, we can say that the minimum value of current occurs at unity power factor. صح ولا غلط؟
Yes.
جميل.
Sure, yes.
We can say here this minimum current, this minimum armature current is corresponding to unity power factor. And then if you continue increasing excitation from EF2 to EF3, the current will increase again up till reaching to a very high values at leading power factors. So increasing here will increase the current again. As you can see, Shabab, the curve is like V letter. For that, we call, or this curve is well known by V curve. Okay, so it's V curve because it takes the shape of V. However, the curve is a relation between armature current and field current. There is no voltage at all. It's completely current. So V curve is the relation between armature and field current. طبعا for V curve we can also plot the power factor curve. Okay, as you can see here, the power factor curve can be considered as a mirror. Okay, a mirror of the current curve. تمام, where power factor is small and lagging at small value of excitation, and when we increase the excitation, power factor will increase to unity, and if we continue increasing, the power factor will decrease again. تمام يا شباب? So this is called V curve and power factor curve according to the different excitation. This is very important شباب to be recognized. طيب, a question. If we have a machine of 5 kVA and we have a load of 3 kilowatt. We have a mechanical load of 3 kilowatt. If we neglect the machine losses, can we, this 5 kVA شباب is the rated value, and the machine now is working at 3 kilowatts, and if the power factor is unity, what is the maximum reactive power that we can achieve without overloading the machine? Again, the question, we have 5 kVA motor, this is rated, this is S rated, and the machine is working at certain loading condition, power equals 3 kilowatt. We have mechanical load which absorbs 3 kilowatt from the machine. Now, the question, how much reactive power the machine can deliver to surrounding loads, طبعا in order to improve the overall power factor, تمام, but without overloading the machine, without overloading, which means S has to be a 5 kVA or lower, without increasing the value of 5 kVA. So how much reactive power we can deliver, شباب?
4 kVR.
Exactly. So we can say the kVA, the reactive power maximum without overloading now will be S rated square, صح? minus loading condition square power. مظبوط? Which will be here 4 kVA reactive. 4 kVA reactive. تمام يا شباب؟ طيب. طبعا if you make it 4 kVA, it means the current will be increased, صح? Compared to the previous case for unity power factor. The current will be increased, but the power is still the same, which means the kilowatt hour meter will calculate only the 3 kilowatts. However, these 4 kiloVAR will be distributed to the around loading, around devices, and this affects the overall absorbed current for all of loads, شباب. تمام? And this will improve the overall power factor. طب if we have, شباب, surrounding loads but not that high, which means they need only 3 kiloVAR. We have 5 kilovolt ampere motor with active power absorbed 3 kilowatts. However, the surrounding loads needs only 3 kiloVAR. What is the optimum case, شباب, here? Is to operate the machine at 4 kiloVAR or 3 kiloVAR?
3.
3 kiloVAR. This is logic. Why? Because if we operate the machine at 3 kiloVAR, this is going to make the overall power factor as unity. صح ولا غلط? Otherwise, yes. If you operate the machine at 4 kiloVAR, so 3 kilovars will go to the loads, and 1 kiloVAR will return back to the grid, which will reduce the power factor again. So it's not logic. تمام يا شباب? So we should generate reactive power according to the surrounding loads, with the limit of keeping the machine without overloading. تمام? So this is the optimum condition for operating synchronous motor at factories. طيب, if you have a synchronous motor without any loads, which means the motor is not used anymore. For instance, يعني in factories they upgrade the machines with their control and so on and leave the old machines. Instead of keeping synchronous motor on shelf, you can get this motor and just connect the motor to the supply without any load and control the excitation. In this case يا شباب, this means you can get the most benefit, which is getting S equal Q. صح ولا غلط? Where B equals 0 in this case. Ideally equals 0, يعني assuming يعني lossless synchronous motor, so the power will be 0. So in this case, you can get Q reactive power equals to S rated. So this is the case شباب, we call it as synchronous condenser. Why synchronous condenser? Because it's like capacitor or condenser. You know, condenser doesn't absorb any active power, where S equal Q. صح ولا غلط? For any capacitor يا شباب.
Yes.
So in this case, we will operate the synchronous motor as a capacitor. So this is a special case or one of the operating modes of synchronous motor. If we operate the motor at no load, which means power equals 0, and even neglecting the losses of the machine, so input power equals 0, in this case, reactive power will be similar to the apparent power of the machine. And in this case, شباب, we can get the most benefit from the synchronous machine. يعني even if there is no use for this machine in factories. تمام يا شباب?
Yes.
But sorry, Doctor, how can the
Yes.
motor deliver the reactive power?
By this way here. طبعا this is the discussion what I just discussed here. Now, how we can convert the motor to deliver this reactive power and act as a capacitor. If you increase the excitation, يعني return back to this shape here. We could convert the power factor from lagging to unity to leading. صح ولا غلط?
Yes.
Now, if we assume the operating point for case number 3, if we increase the excitation more, what will happen to the current?
قلت 90 degree.
It will go increase again and so on up till making the excitation very high, and even when we remove the load, so delta will be 0. So this is going to make EF in phase with V terminal. صح? And this is ideal condition. This is the ideal condition where there is no consumed losses at the motor. Okay, and this is ideal case, not practical. تمام? For that, if we have a look here again, for that, at high excitation value, the current will be almost at 90 degrees. طيب, طبعا يا شباب, if the motor is well designed and we calculated the loss, the core losses and no load losses of the motor, it will be very small also. تمام? Which means يعني instead of having current at 90 degrees, it will act like, for instance, 89, 88 point something. So let me ask you a question. If the capacitor completely capacitance without equivalent resistance?
No.
Even the capacitor. So we cannot say capacitor is exactly or sharp 90 degrees current. It will include also very small resistance called equivalent resistance or series equivalent resistance for the capacitor itself. So we can say now synchronous motor at no load is like a capacitor, even practical capacitor, where practical capacitor as well is not pure capacitive. It has يعني very small equivalent resistance as well. تمام يا شباب؟
Yes, Doctor.
تفضل.
When we say that synchronous motor is with no load, it means with very high field excitation, right?
لا, كلمة no load, it means there is no any mechanical load coupled to the motor, so power angle will be 0. This is the meaning of no load.
Yeah. And
but
we are using
but increasing field or decreasing field will affect now the current to be lagging or leading. يعني at certain value for increasing, you will get lead current by around 90 degrees or 90 degrees ideally. If you decrease the excitation, the opposite will happen. It will be lagging by 90 degrees and it will act like inductor. تمام؟ يعني here in the upper phasor diagram, this is the case of 0 power factor leading. However, the lower diagram is 0 power factor lagging. تمام؟
Yes.
طيب. Any question يا شباب in this part?
Yes.
اتفضل.
We said what I know that when the current is lagging, we deliver the VARs.
لا تاني سؤال تاني معلش.
What I know from previous that when the current is lagging, we are producing the VARs, not leading.
You mean you deliver reactive power or consume يعني؟
Yes.
طيب يعني the meaning يعني maybe it was confusing for you. The meaning of lag يا شباب that reactive power is moving from generator to loads or supply to load. يعني let's make it more general. Instead of saying generator, let's say supply. So the mean of lagging power يا شباب, it means reactive power is moving from supply to load. طيب, if you now said the machine is working as generator, which is a supply, so if the machine is lagging, it means the generator is delivering reactive power to load. طيب, if the machine is work as a motor, which is load, if we say the motor is lag, this means the load or the motor is consuming reactive power. So this is the meaning of lag يا شباب. Meaning of lag is the reactive power traveling from supply to load. And the opposite is for a lead. تمام? This is the meaning of lagging and leading power factor or reactive power. تمام يا شباب؟
Yes.
Okay. Good. يعني time is not enough to continue solving problems today. يعني I wish this يعني class is different شباب because we started solving more questions. Inshallah we will continue solving problems next classes, and after finishing يعني I believe we have few points to be discussed here in this slides. يعني few discussions and we will continue solving problems إن شاء الله تعالى. Okay, any question يا شباب؟
دكتور عندي سؤال عن الاكسبيرمنت الريبورت.
طيب اوكي يعني let me يعني stop recording and you can ask.